everybody, I'm Kajal Mehra from TimesTech, and we are here at SEMICON India 2025. And with us today is Mr. Shitendra Bhattacharya,
Hi.
the country head at National Instrument, which is Emerson. Hi, Shitendra.
Hi,
Welcome.
good afternoon. Thank you.
Could you please introduce a little bit more about Emerson and yourself as well?
Sure. So, Emerson is a global automation company, and NI is a test and measurement company which was acquired by Emerson in October 2023.
Okay.
So, now we operate as a test and measurement business group of Emerson. So, if you have known NI in the past, we continue to be that same brand, offering the same set of solutions, just under the Emerson umbrella. So, that's the change that's happened since October 2023, and yeah, well, it's been going well so far.
Perfect. So let's move ahead to the Q&A session. So my first question is that Emerson has been leveraging AI and data analytics to accelerate semiconductor product development. Can you share specific ways these technologies are helping reduce time to market and improve efficiency?
Okay. Yeah. So with some of our flagship products like LabVIEW and TestStand, LabVIEW is a graphical programming language and TestStand is a test automation software. We have introduced something called as the Nigel Advisor, which is basically an engineer-led AI-enabled capability that we've introduced into our software. And that, in combination with our powerful hardware that we have, we are able to now deliver intelligent test systems to our customers. Right? So the intelligent test systems is not just about it just being AI-enabled, but it is also creating adaptive test systems. So with every test cycle that you run, you're able to learn a lot more about the data, about the test, and then evolve into the next test cycle. Right? So that's the capabilities that we're able to now bring in to our customers. So definitely it adds a lot more value to customers because we are now able to eliminate some of the low value tasks through the AI capabilities in the software. We are streamlining workflows, so that allows for easily developed software workflows which are connected across the different development phases of the product. And at the end of it, we are also able to provide data analytics capabilities because there's a huge amount of test data that you collect when you're testing for any dot, but you need to be able to provide valuable business insights to that. And so that's done with our analytics software. So the combination of all of these, we're able to add a lot more value to our customers, reduce the time to market significantly.
So validation is often seen as a bottleneck in chip design and packaging. How are Emerson's automated test system helping customers overcome these challenges?
Right. Yeah. So validation can be a very resource-intensive process, and the number of iterations that you need to run on a validation process is quite intensive, or actually quite time-consuming as well. So what our platform does is we, with the help of a PXI architecture, which is modular in nature, we have an open, flexible software and a completely scalable system in collaboration with our ecosystem and with the data analytics capabilities that we have. If you combine the modularity, flexibility, scalability, the openness of the software, the ecosystem, and the data analytics capabilities, we are able to reduce the validation cycle significantly. So what I just mentioned previously, right? We are removing all the low value added tasks. We are streamlining the workflows. So, and there is, with every test cycle, with every test iteration, we are learning more about the dot and then adapting the kind of test that needs to be done. So this is reducing the time significantly. So whether it be in the validation phase or the production phase, the test cycle is reduced. So we do, with the capabilities of our entire platform, we are able to reduce the test time significantly, which eventually allows for products to come out much faster into the market.
Okay. Your modular open test platforms are positioned as scalable solutions. Could you explain how this approach enables flexibility for customers in such a rapidly evolving ecosystem?
Yeah. So the innovation is happening at breakneck speed. And I think whether it be for servers or 5G, 6G or defense applications, the complexity is only increasing, right? So, for example, chip design has now become more heterogeneous in nature. Reliability is becoming a lot more important because of all mission critical applications. You want to then continue to provide high performance chips at lowest of power, right? So what actually is needed is all of these capabilities are coming in at such a high speed that your test systems also need to be evolving at a much faster speed, right? Now, it could be extremely expensive if you to keep overhauling your infrastructure very often.
Exactly.
So what we're able to do is, one is because of the modularity, we are able to now, so each of these instruments are able to come in the form of a card. So the PXI architecture is such that you have a card cage and then you have instruments that you can plug into that card cage.
Okay.
So the real estate is significantly lower, right? And it's very powerful because you have very high performance computing on that same platform. Then with the flexibility now, because of the open software that we have, you can actually build the software. These are all software-defined instruments. So basis of the software that you're loading onto the PXI, it can function in a certain way. The uniqueness of our platform is whether it be an application in the aerospace and defense industry or in the semiconductor world or for a transportation application, it's the same platform and the same core software that is used. So it's very easy to evolve into whatever the complexity of the application be or whatever the duty you're trying to test. And then lastly is the scalability aspect, right? Today, if you're testing a low complex DUT, and then tomorrow you need to change it to a high complex DUT, or the number of channels that you're testing is increasing, or for example, you're moving from validation to production, so then the throughput needs to go up. It's all the same platform. So it's just easy for me, like if I have a certain kind of instruments with a certain number of channels, I can just plug in more of those if my channel count has to go up. And I can just, with a few minor tweaks to the software in very low amount of time, I can just easily scale my application to change from a lab system to a production system onto the floor. So these capabilities are able to, the customers are basically leveraging this value significantly. So people who are standardized on this platform are able to, really see the value of how time to market can be reduced. The total cost of ownership is lower.
Cool. So, what major trends do you see in the semiconductor design and reliability testing, particularly with the rise of AI-driven insights?
Yeah. So, again, I think like I was mentioning, the 6G is there, defense capabilities are increasing significantly. You have electric vehicles, you have, now fusion of sensors. So, the chips are becoming more and more capable, are able to make decisions on the node with a lot of processing happening at the lowest amount of time, right? So that's an evolution that's happening. So like I mentioned previously, chip design is becoming heterogeneous.
Yes.
Reliability is becoming more critical. Power has to be least, performance has to be highest. Right? And then with AI capabilities, decision making has to be faster. So these are the trends that are evolving for sure. I mean, that's the fundamental trends, irrespective of the application. So the test systems also need to be able to cater to that. So for example, if I have to test for analog, mixed signal, RF combined, you need to have a test system which can do all of it together, right? So that means you need to have those kind of instruments available in a smaller real estate because space is also a problem today. You cannot have like a huge, test infrastructure facility available with so many boxes. You need to have it in a more compact form factor. So those are some of the capabilities that we have designed on our platforms, which we are offering to our customers as well. So as these trends keep evolving, we are also staying abreast with the latest and able to provide that value to our customers.
Okay. So with India aiming to become a global semiconductor hub, what role does Emerson see itself playing in supporting this ambition?
So we are working with all the companies who are making investments into India. You see, right now, the way this is working is there are Indian companies who are funding to set up OSATs and fabs.
Yes.
They need to work with technology partners. So we work with the technology partners at a global scale. We work with most of the semiconductor companies at a global level. So we are bringing in the global expertise that we have developed over many, many years now into the country, right? We have been in India for more than 25 years.
Okay.
So our capabilities are also evolving as the market is changing.
Yes.
We have the largest R&D center outside of our headquarters in India, who are supporting, some of the softwares that we develop, our flagship products. The R&D work happens out of India. We also have an engineering innovation center that's based out of Bangalore.
Okay.
So that's also able to provide access to engineers and scientists as they need access to some of these cutting edge technology. We run a program called the Technology Accelerator Program, which is basically to support all startups. As the India Semiconductor Mission is evolving, we see a lot more startups coming into play.
Yes, yes.
So we help startups come and get access to our Engineering Innovation Center. We get access to our technology, get access to our engineers, get access to some of our software at a much easy way of getting access to it. We also offer a lot of training, so they get trained and skilled. We collaborate with organizations like CDAC, for example, who have their chip-in center to support the startup community. So they work with us quite closely. And then at the end of it all, we have a very strong university program. So we are able to work with university folks, students essentially, teach them fundamental concepts of engineering, basic system design concepts, research. So they are also able to get skilled, and then now we are partnering with a few universities to collaborate with them to build some of the semiconductor coursework that is needed for them with the help of our software and our hardware platform.
That's perfect. So, beyond semiconductors, immersion expertise extend to automotive, aerospace, and wireless communication. How do innovation in these industries intersect with your semiconductor test and measurement solutions?
So, like I was mentioning previously, irrespective of the industry type, our platform is the same. It is the same PXI architecture platform that we offer, which is modular, flexible, and scalable. We have an open software, we have data analytics as a layer, and we have an ecosystem. So it's this combination of these four components which are able to serve any industry. That's the beauty of this platform, right? So yes, there is different rates of innovation that's happening, and all of them are happening at really fast speed. But because of these core fundamentals remaining the same, and we are evolving that, like for example, recently, like I mentioned, we introduced the AI capabilities, right?
Yes.
So what we are doing with AI is we are keeping it engineer-led, we are keeping it AI-enabled, right? And we are working with the most renowned industries using industrial standards for AI, and that allows security becomes a concern. You want to ensure that it is responsibly used, and you don't want to eliminate an engineer's capability because of the possibility of AI on your test and measurement, right? So with these three fundamentals, with the core evolution on the hardware, so essentially what we would do, we would make our software significantly faster, which is now providing more connected workflows to our customers. We are introducing more and more capabilities on our modular hardware itself. So for example, the frequency ranges of coverage that we would provide would go up because the DUTs would need higher frequency. The resolutions of our hardware will improve as DUTs need higher resolution and so on. So those are innovations that we will continue to keep doing on the PXI platform, and we will keep enhancing our software capabilities to provide more value to the customer.
That was my last question, by the way.
All right.
Thank you so
Thank you.
much. Thank you so much for your
Thanks.
time
Thank you.
and insights.
Thank you.
And thank you so much for watching us.
Thank you.